Donuts. Circular motion in physics and how it relates to acceleration and velocity. But we're not talking about these donuts. They're very delicious, but they have very little to do with physics. We're talking about these donuts. So how do cars do this? The first thing we need to talk about is circular motion. So what is circular motion? Circular motion is the movement of an object along the circumference of a circle or the rotation along a circular path. For our example, we used a toy car moving in a circle. Let's go ahead and watch this. So what are the features of circular motion? Circular motion is a uniform motion and it's constantly changing direction. The velocity vector is directly tangent to the circle and will move tangent to the circle as it's going around. So this is what it looks like. The velocity vector tangent to the circle and the acceleration going in. The acceleration is always pointing internally, and there is constant acceleration due to the constant change in direction. The inward direction of the forces causes the change in direction with the velocity vector angling inward, creating the circular motion. The acceleration points to the center, creating that net force. Net force towards the center of the circle is required to obtain this motion. The force towards the center of the circle causes velocity to change in that direction, creating circular motion. Other features of circular motion are that without the inward force, a vector would travel along in a straight line. With the force, the movement should be as follows. The net force points inward towards the center of the circle, but this means that all other forces are lesser than that of the one moving inward. The forces that affect the car are a normal force, which will usually point upwards if we were looking at the back of the car, weight which will point downwards, and then a static friction force that moves towards the center. Static friction force with the tires and ground is creating a necessary force that will tilt the car and move it in the circular direction. Next, we found the velocity of our car. This was calculated by doing the equation for velocity, which is 2 pi r over t, or 2 pi times the radius of our circle divided by time. So let's see how the velocity looks on our car.
The data was placed into the video analysis system, which calculated the points and was able to determine the velocity and the velocity vectors of the car going around in the circle. The time is displayed on the x graph right here, and the meters is displayed on the y-axis. And together we can see their interaction with one another, which was converted into the velocity graph seen here. And based on this information, the velocity should be around 1.7 or 1.8. Now with our information, we can calculate this manually by using the equation for velocity. This equation comes from the calculation of the circumference of the circle, which is c equals 2 pi radius, and the distance around the circle of the circumference divided by time is equal to the velocity. So we see with our information, our t was 3.68 seconds, our radius was 1.016 meters, and placed into the formula, we have velocity is equal to 2 pi 1.016 meters divided by 3.68 seconds, which gives a velocity of 1.735, which was what was predicted based on our graph of around 1.7 to 1.8. Now to determine the acceleration of our car. Using the video analysis once again with the same information, we're able to see the acceleration vectors all pointed toward the center with our car. We can see with the information we have obtained from our previous trials that our radius is 1.016 meters, so we see that right here. Our velocity is 1.735 meters per second, and now we just need to calculate the acceleration. The equation for the acceleration is velocity squared divided by the radius. Our acceleration would then be 1.735 meters per second squared divided by 1.016. And then our acceleration is now 2.963 meters per second squared. So completed, these are the features of our car's circular motion, with our acceleration pointed inward at 2.963 1.6 meters per second squared and the velocity of 1.735 meters per second. Woo! Now you know about circular motion.